Good morning, everybody. Happy Monday. Hope everybody is warm and safe. Did y'all get snow? I got snow. I had snow. So I was in for the weekend, just looking at the snow. Trying to get everybody in. There always seems to be one person who is joining and gets stuck. All right. Gabriella, it looks like you're in, but you're still on my admit in the waiting room list. All right. We had a test last time we met. Y'all did good. Is there anybody who needs to take the test? I think everybody took it, but is there anybody who needs to take the test? Because I need to give you a code. All right. And while we're still waiting for folks to come in, we're starting a new chapter doing. So we've been looking at this semester the impact of humans or the human impact. So last one, it was land. This time it's going to be air and water. This is a short. Okay, Max. Give you the code. Let's see what that was. I think it's still open, but let me know if it's not still open. It should be. All right. So again, we're going to be looking at the impact of air and water. So we will talk about pollution in general, and then take them air separately and then water separately. So we did land pollution last time. I'm trying to give it a minute to let everybody in. But as always, you can um, go in Canvas and look at the overview page while you're waiting for everybody to come in. Look at our 3 questions. What is air pollution? We're going to talk about what is pollution in general. The effects of air pollution, what is water pollution, and the effects of water pollution. And take a look at the list of vocabulary words while we're waiting for folks to come in. I think we're almost there. All righty. All right, good morning, good morning. If you just came in and you missed the test last Thursday, please let me know. I need to give you the code. All righty. Also, if you just came in, wait, I'm gonna wait. Okay. Righty. There we go. All right, I think we got everybody today. Happy Monday. Happy Monday. Or Merry Monday. Marvelous Monday. All right, we set the internet doing wacky things already. People popping in and out, and it's just the beginning of the day. All right, I think we got everybody now. Full class. Yay. Good, good. All right, so again, if you missed the test the other day, I see that. I don't know why, but you're only visible. I see you on my, that's so weird. You're on the admit list just once, but you are on the screen twice. Your picture is only up once. I'm going to assume that it will disappear. It wasn't. Okay. I'm assuming it will update Camilla. And up, I think it already has. All right. So now you're just in once. All righty. Yeah, the Zoom is doing some strange things. Like I said, people have already been in and out. And we just started the morning. But okay. All right. So since everybody's in, and I think everybody who needed to take the test has asked for the code, we're all good. All right. So we're going to, like I said, we're going to be looking at the Canvas unit on human impact on air and water. And before we start that, well, let's look at this one first. Keeps trying. Zoom is messing with folks this morning. All of a sudden, somebody got kicked out. Lost 2 people. It's not talking to you. And we're going to, this one is also short, but she'll talk to you.
I feel like anytime I post about my life as a teacher, especially when I post what I do after school, people always ask, how do I...
Air pollution consists of chemicals or particles in the atmosphere that pose serious health and environmental threats. But what causes air pollution, and what does it mean for our planet? Some air pollution comes from natural sources like volcanic eruptions, wildfires, or allergens. But most air pollution results from human activities such as energy use and agriculture. There are different types of human-made air pollution. When we burn fossil fuels to produce energy, they release greenhouse gases into the air. These emissions, such as carbon dioxide, methane, nitrous oxide, and fluorinated gases, trap heat from the sun in Earth's atmosphere, leading to a rise in global temperatures. This creates a cycle where air pollution contributes to climate change, and climate change creates higher temperatures. In turn, higher temperatures intensify some types of air pollution. For example, climate change increases smog because it forms in the presence of high heat and increased levels of ultraviolet radiation. More frequent extreme weather, such as flooding, contributes to damp conditions and therefore to a rise in mold. Warmer weather also leads to longer pollen seasons and therefore more pollen production. Smog is a type of air pollution that reduces visibility and has serious health effects. Smog can be divided into two categories: sulfurous and photochemical. Sulfurous smog is made up of chemical compounds called sulfur oxides. It occurs when burning sulfur-bearing fossil fuels such as coal. Photochemical smog, also called ground-level ozone, is a result of the reaction between sunlight, nitrogen oxides, and volatile organic compounds. Nitrogen oxides come from car exhaust, coal power plants, and factory emissions. Volatile organic compounds are released from gasoline, paints, and many cleaning solvents. Smog not only creates a brown haze that reduces visibility, but also harms plants, irritates the eyes, and causes respiratory distress. Another category of air pollution is toxic pollutants. These are chemicals such as mercury, lead, dioxins, and benzene that are released during gas or coal combustion, waste incineration, or burning of gasoline. In addition to adverse environmental effects, toxic air pollution can cause serious health problems such as cancer, reproductive complications, and birth defects. While air pollution has many consequences for our planet, there are solutions. We can limit toxic pollutants, smog, and greenhouse gases by decreasing the use of fossil fuels, such as in transportation, manufacturing, and electricity generation. Reducing air pollution not only contributes to a cleaner environment and better human health, but can also slow the rate of global warming.
Okay, so that one is in your playlist. There we go. All right, so what I want you to do while I do attendance is to, again, look over the overview, take a look at the vocabulary, and then move to what is air pollution. Okay, so they touched on it a lot in the video just now. So take a look at this page. There's a lot of vocabulary with this part. Oops, did not mean to do that. So, and they went through these vocabulary words. So we're going to go through these because you do have to know them. And then I'm going to share I'm not going to take the chance that you all can't get to it, but we're going to look at an interactive map so that we can look at what the air quality is in our area at the moment. And I'll put the link in the chat, but I don't know that you'll be able to log into it. It might be one of those things that's just blocked. But read this page over while I do attendance, please. All right, and again, is there anybody else who needs the code for the test? I only see 4 people really looking at the air pollution page. Justin. Is Justin here? Justin, you need to take the test. Um, Sarai, you need to take the test. Because I don't have scores for you. Evan, I don't have a score for you either. Nice. All right, so I just called your name and I just sent you a code. Please take the test. It closes today, and being as you are here today, if you don't take it, it's a 0. Evan, I believe you just logged in to be logged in. All right, Sarai, please take the test. All righty, moving on, moving on. All right, so the important thing you need to remember is air pollution can come from man-made sources or natural sources. There are certain things in nature that actually create pollution. I'm going to look at that. And those are not so much the problem as the man-made ones, because the man-made ones, nature tends to balance itself out, but the man-made ones tend to be the ones as the population grows, so does the problem grow bigger as well. All right, we have two types of ozone. The ozone that is in the atmosphere that actually is good for us because it blocks out harmful radiation. But because of the pollution that we're creating, we're putting holes in it. So imagine having a blanket and it's old and it's got holes in it. You get air drafts coming through the blanket. So this is when we say ozone depletion due to air pollution. That's what we're talking about. It is actually a layer in the atmosphere, and it's a good layer. But then we have ground level ozone, which is a different type of ozone. So we're going to look at those differences as well. So we're going to look at the layers of the atmosphere as well as types of pollution. All right, so so definitely read all of the little side pieces. And thing we need to talk about is that there is primary pollution and secondary pollution. There are two types. Primary usually produced um, from a process such as volcanic eruptions, and notice that's natural. Carbon monoxide gas from motor vehicles, that is not natural. And sulfur dioxide released from factories, also not natural. So last two are man-made. Volcanic eruptions don't happen often, but when they do, they create a tremendous amount of air pollution. All right, secondary pollutants are not emitted directly, but are formed in the air when primary pollutants react or interact. And ground level ozone is one of those. So the types of things that get emitted from your car, when they combine with other things, they create ground level ozone. All righty. We'll stop there for a minute, and I wanted to share this map with you. I'm gonna put this in the chat, and you can let me know whether you can um, get to it or not. Home based. There we go. All right, so that'll take you to this. The link I just put in the chat will take you to this. So we're gonna click over here. And let's see, what do we want to know? We want to know ozone, we want to know we'll just click on, let's see, let's do it like that. Okay, so right now, oops, too much. All right. So right now we're green, and that's because it's cold. So right now you'll find that when it's cold, that's a good time for good air quality. So we're going to look at an air quality. This is Georgia, and they have different stations where they monitor these things from. So assuming that I clicked, I was trying to get it big enough so that we can actually click on the right place. All right, so Columbus, there we go. All righty. Columbus Airport. They're not giving you any information about that at all. But it is yellow, which means there, and that's because that's the airport. So there is some degree of pollution there, and I would guess that this 55 up here is the Atlanta airport. No, that's Gwinnett Tech. Okay. Uh-huh. That's the college. Let's see what. All righty. Now, let's look at, is that current? That was current forecast. And we're still looking at yellow. All righty. So that gives us an idea of what, it's flipping back and forth here. All right, so we're going to keep that in mind, that you had, let's go back to current. All right, so currently in Columbus, we've got 58 parts per million. So we're going to look at, see what does that mean in a little while.
Air pollution is not a new phenomenon. By the mid-1600s, London's air had reached a point that it attracted the attention of one of the greatest minds of the time, John Evelyn. In 1661, he published a book entitled Fumifugium, or The Inconvenience of the Air and Smoke of London Dissipated. The pamphlet was a call to clean up the air of the City of London. It described the effects of air pollution caused by coal burning on the population of London, and he wrote, "In London, her inhabitants breathe nothing but an impure and thick mist, accompanied by a fuliginous and filthy vapour, which renders them obnoxious to 1,000 inconveniences, corrupting the lungs and disordering the entire habit of their bodies, so that catarrhs, phthisics, coughs and consumptions rage more in this one city than the whole earth besides." Evelyn suggested that burning wood instead of coal would be less harmful to the lungs and recommended relocating some of London's most polluting industries outside of the city. With increasing industrialization, there was a string of parliamentary acts in the mid-19th century designed to do something about the polluting effects of industrial and domestic smoke. London was infamous for its combination of smoke and fog, combined in the word smog. For this reason, London earned the nickname the Big Smoke. All major cities suffered from smoke pollution, and Edinburgh's nickname, Old Reekie, refers partly to the sanitary situation of the town as well as smoke pollution. London became quite infamous for its smogs, and many visitors came to see the capital in the fog, not least the artist Monet. He painted the atmospheric conditions and sunsets caused by the smog many times during his visits in the years between 1899 and 1901. A recent study has shown that Monet's paintings of the Houses of Parliament were not created from his imagination, but that these were firmly based on actual observations made during the artist's visits to London. It is perhaps the earliest visual record of the great smogs of London. Notwithstanding its artistic qualities, the London smog could literally be a killer. A week of smog in 1873 killed over 700 people in London. However, the largest air pollution disaster in Britain was the Great London Smog of 1952. On December the 4th, 1952, an anticyclone settled over London. The wind dropped, the air grew damp, and an inversion layer trapped the air, which received smoke of 3.5 million chimneys and many industrial smokestacks. Visibility dropped to a few meters, and smoke levels rose 300%, and the sulfur dioxide levels rose by 700%. It is therefore hardly surprising that this led to around 4,000 deaths. The peak in the number of deaths coincided with the peak in both smoke and sulfur dioxide pollution levels. In the aftermath of the Great London Smog of 1952, the government passed the two Clean Air Acts of 1956 and 1968. The aim of the acts was to control domestic sources of smoke pollution by introducing so-called smokeless zones and control industrial sources of pollution by the use of tall chimneys for waste gas dispersal. The reduction of domestic and industrial coal burning and the use of smokeless fuels led to a reduction in the levels of emissions of smoke and sulfur dioxide, which is one of the main contributors to acid rain. Between 1970 and 1994 emissions fell by 60%. Although these measures worked reasonably well, the smog problem disappeared from London and other European cities due to a change in fuel. The switch to gas heating and also using gas for electricity generation made this kind of smog a thing of the past. However, with the rise of car traffic, we got a new kind of smog, photochemical smog. This kind of smog is caused by carbohydrates, which are produced by the millions of cars driving around. This is the famous Los Angeles smog.
Thank you. All right. You want to make sure that you click on all the little icons so that we're looking at carbon monoxide and carbon dioxide are both colorless, odorless gases. They are both toxic. So carbon monoxide is toxic to both plants and animals, which means it can be deadly. I know you've seen all the TV shows where they go sit in the car and inhale the exhaust. And there are certain rock formations that also emit carbon monoxide. So a lot of houses now have carbon monoxide detectors because this can be quite dangerous. It's probably part of your insurance policy as well, that you have at least one carbon monoxide detector in the house. If you don't, you should check on that. All right, carbon dioxide is good and it's necessary for photosynthesis. However, too much carbon dioxide is what is making the atmosphere very thick. I think I mentioned it some time back that think of carbon dioxide as the nice fuzzy blanket that we have around the earth. It is what keeps our planet warm and makes the planet livable. But if we keep emitting carbon dioxide, our little blanket gets thicker and thicker and our planet gets warmer and warmer. And this is what's going on now. So this is what we are calling climate change, that because the blanket is getting warmer and thicker, we are having weird weather like the snow we keep having in January. This is Georgia. You're not supposed to have snow in Georgia. But we have been, last couple of years, that's been happening, and ice storms and weird changes in the weather are happening because of climate change. All righty. This is nitrogen oxides, and there is nitrogen monoxide and nitrogen dioxide. And they are naturally produced in nature, but they are also produced by exhaust from cars and factories and power plants, and they're not necessary, and they contribute to acid rain. And acid rain just means that when this particular gas combines with water, it creates an acid, and then it precipitates and causes damage to the surface of buildings and animals and things like that. All right, so you're going to see that a lot. Okay, same again, sulfur dioxide. and sulfur trioxide are the gases that are here. They come from when you're burning coal, and they also combine with the rain with the water to form an acid. And when it precipitates again, causes problems. All right, here's our ozone. And this ozone that we're talking about is the pollutant ozone, not the ozone layer in the atmosphere. Okay, and it takes place at ground level and helps to create smog. But it is also one of the greenhouse gases. All right, VOCs. So you need to know that VOC stands for volatile organic compounds, mostly hydrocarbons. And hydrocarbons are methane. So we are switching to methane gases. I know in Atlanta they have buses that run on methane gas, and that's all well and good because it's cleaner than burning gasoline. However, it gets in the atmosphere and adds too much methane to the atmosphere. All right, chlorofluorocarbons. Those are the things that they used to put in aerosol sprays. And when they get in the atmosphere, they combine with oxygen and create the molecule of ozone, which is not what they need to do. So they've changed the chemical that they put in spray cans. They're encouraging you to use more roll-on deodorants and pump sprays instead of aerosol sprays, because it's the gas that they put in the can to project the chemicals is what causes causes the pollutant. And we get to the bottom of the can and there's nothing left, but we're still spraying that. Well, the stuff that you're spraying at the end is no longer the thing that you want. It's the chemical that they put in there to propel the other chemical that you do want out of the can. Particulates are the solid particles such as ash, dust, fecal matter, which are commonly formed in combustion of fossil fuels, meaning the burning of coal or gasoline. These often produce smog and are bad for asthma and can cause heart disease and some types of cancer. This also happens, you get particulate matter when volcanoes erupt because you get a lot of ash and dust. Explosions cause this as well. All right, lead. Notice now they used to have lead in the gasoline, and they've removed it from the gasoline and the paint. So they're aware of this one, so it's not as bad as it used to be, but it is a heavy metal and it can cause brain damage or blood poisoning. Okay, photochemical smog are those that come when the car exhaust is exposed to sunlight. So again, this is secondary. So you have the pollutant and then it's exposed to something else and creates a whole different type of pollution, secondary pollution. All right, so then it can also go in reverse. So on warm days, surrounded by mountains in Los Angeles and Denver, especially prone to photochemical smog. So we don't have that much problem here, except Tennessee, northern Georgia, where they have the mountain chain going through. They may have this. There's the Smoky Mountains. Sometimes that's not all clouds up there. That can be smog. All right. And then here again, we need to know the difference between primary pollution and Secondary pollution are the result of human activities, direct emissions from vehicles and smokestacks, and secondary form in the atmosphere. So when the pollutants that we are that the man-made pollutants get into the atmosphere and they combine with oxygen and other pollutants, they can form ozone, they can form sulfuric and nitric acid, particulate matter, nitrogen dioxide, and peroxyl nitrates, PANs. All right. So we looked at air quality, and I'm going to give you a chart, an air quality chart. This is going to work. All right, this one is not work. So many of these things don't work. Oh, there it goes. Well, it's not really going, is it? All right, well, I'll have a challenge for you later.
To research how biomass burning in Africa impacts the Earth's atmosphere, a group of scientists took their highly sensitive measurement equipment and traveled from Germany to the Cape Verde Islands, downwind of Central Africa. For 4 weeks, the Atlantic island of Sal was home to around 40 researchers. One of them was Ivan from Mainz. Although Sal attracts tourists, the 26-year-old scientist did not spend his time on the beach. His workplace was the hangar of the local airport, as well as an aircraft. His measuring device was part of a comprehensive payload that was mounted in the research aircraft Halo.
The project is called CAFE. It's part of my PhD thesis, where we are quantifying trace gases and particle distributions in the troposphere, upper troposphere, lower stratosphere, with a set of 20 instruments aboard. And what I'm doing is I'm supervising NOx measurements. NOx is NO and NO2 on board this Halo aircraft to quantify biomass burning effects in the upper troposphere, lower stratosphere, to tune model simulation calculations of NOx.
Ivan was part of the CAFE Africa team. CAFE Africa is an abbreviation for Chemistry of the Atmosphere Field Experiment in Africa, a mission coordinated by the Max Planck Institute for Chemistry. Some of the scientists and support staff included colleagues of the German Aerospace Center, the University of Wuppertal and the University of Heidelberg.
Africa is a big continent and there is a lot of action. There is biomass burning from forest fires and savanna fires. There is a lot of dust coming out of Africa, and the pollution sources are growing tremendously, like in Nigeria and other countries. And we want to know in CAFE Africa how these pollutants are being mixed and transported by the African monsoon and are then redistributed on a global scale.
The scientists used the aircraft Halo, which is equipped to measure many gases and particles and has different inlets to channel the undisturbed air into the measurement instrumentation on board Halo. Halo stands for High Altitude Long Range Research Aircraft.
Halo is a Gulfstream 550.
Halo is a Gulfstream 450 aircraft that has been chosen because it can fly very long and high, which is of crucial importance for today's climate research. Furthermore, a lot of changes have been made in the aircraft's construction. For instance, a lot of holes in which air inlets can be screwed. The inlets deliver air samples into the cabin, where analytic devices control the substances.
Die Inhaltsstoffe kontrollieren.
We expect that, especially from the biomass burning, which is on a very large scale in Africa, there's a lot of organics being released into the atmosphere. And these organics can be measured as gases and partly also as particles. So we measure the entire spectrum of gases and particles.
So we're operating a set of 20 measurements aboard Halo, and apart from the fact that measurement flights can take up to 10 hours, it's very loud, noisy inside this aircraft, and all these facts come together to make the complexity of the flight to operator and instrument.
While Ivan and 3 colleagues flew over the Atlantic, he maintained contact with the other scientists on the ground, who received data directly via satellite. This also allowed them to discuss solutions when a device did not operate optimally.
During one measurement flight, we encountered highly elevated NOx values beside cumulonimbus clouds, and we had this NOx coming out from these clouds. And it was pretty interesting because this NOx event we were detecting the NOx for roughly 1 hour.
In total, the scientists flew 16 times from Celle in the direction of the African coast and out over the Atlantic. The data analysis will take several months. The unique measurement data will help investigate how air pollution, dust from the Sahara, and biomass burning emissions affect the atmosphere and our climate. Another thing is certain at this stage. Ivan will also take part in the second part of the mission that will take place in 2020. Then the Halo aircraft will bring the Mainz-based scientists to South America in the CAFE Brazil campaign. There is little doubt that Ivan will not forget the exciting flights with Halo over Africa.
Okay. Can anybody tell me, just put in the chat, what is biomass? What is burning? Why is biomass such a big deal in an area like that? What is biomass? I'm gonna ask, that's gonna be a test question. What is biomass? Somebody, anybody? All right, plant and animal waste. Thank you, Anthony. When we're burning things that come from biological things, living things, when we burn those types of things. Okay, so burning trees, burning leftover garbage from food, that's biomass. Now, lately, we're trying to, and on this side of the world, we're trying to use biomass in order as a way of cheap energy, but they harness it. So harness the pollution part of it so that it's not so dangerous. But that is one of our sources of fuel. All right. Now they were looking at it over Africa, but again, when we have incidents like volcanic eruptions that happen on the Pacific side of, so they were more on the Atlantic, but we also have issues. There's a whole chain of volcanoes up and down the Atlantic side, and they tend to erupt. The ones in Hawaii have recently erupted, and they create particulate matter that cause pollution. All right, and as with everything, there's going to be laws because it's become a serious thing. We can't just keep doing what we want to do and how we want to do it. So they have to create a law. So there is a law called the Clean Air Act, and its job is but it was written so long ago, 1970. Most of y'all weren't even born yet. And the issue with that now is that we're doing different things now. There's new technologies. So we really do need to, as a country, revisit our Clean Air Act. Okay, but it has functioned to make the United States cleaner, more visibility, and people no longer are incapacitated by industrial smog. Like they showed you in the earlier video where London, they had to wear masks all the time because of the pollution was so bad when they first started industrializing, because in order to create industry, they had to burn fossil fuels. And so we don't burn fossil fuels as much anymore. They've switched more to other cleaner sources of energy. Where they can do hydroelectric, they do that. Where they can put in solar panels, they do that. So they're getting away from burning fossil fuels, but it's still a process. It's still a process, right? In the time that's left, there's a few more minutes left. Finish reading this page. Look at the chart. Like I said, next class I'm going to have another chart for you on. It might be on the next page. And I'm going to have there it is. All right, that's the chart I want you to look at. So we're going to study this. And as you saw, we're in our area, or Columbus, you were in like 55. So when you were in the yellow zone, you want to be in the green zone. So even in this winter time, people who are sensitive to heavy odors in the atmosphere need to beware. But that's where we were when we looked at that map for the Columbus area. All right. So if you finish with the first page, go ahead to look at this second page on pollution, because this is where we're going to head to on. I have some questions for you about this and health problems that arise from air pollution. Case studies. All right. So again, with the few minutes that are left, just continue reading the first section and go ahead and start reading this second section and take a look at this chart. So we're going to give you a color-coded question on the test. We'll ask you which color is a good day and which is a bad day. And obviously green is always going to be good. But what do these other colors indicate? Also, remember that pollution is measured in parts per million. That is, everything has a unit of measurement. The unit of measurement for air quality is parts per million. How many particles of pollutant are in the atmosphere per million drops of air, particles of air? Okay. I still do have 3 people who have not taken the test. Oh, not even present. Folks, you got people who log in for attendance and then are idle for a whole class. And then when I have messages for you, you don't respond to them. Like, take the test.